This is a very old microwave oven. This is a Kenmore model 99421, which was manufactured in 1981. I purchased this microwave oven secondhand in the early 1990s, and I've been using it every day. So as of the making of this video, which is in the year 2023, that means I've used this microwave oven approximately 30 years, give or take. And I use it multiple times every day, and I still use it. It still works. Sort of an example of the adage, they don't make them like they used to. It is a fact that home appliances are diminishing both in quality and longevity as producers compete more directly on price than anything else. But this microwave oven does have a problem. When I purchased this microwave oven, I was lucky enough to also get the manual. Kenmore, which was the trade name for home appliances from Sears and Roebuck. And once upon a time, Sears was the biggest retailer in the world, and certainly in America, and they sold absolutely everything you would ever want to put in your house. Unfortunately, Sears fell victim to more nimble competitors, and today it is just a memory, trampled to death by the likes of Walmart and Best Buy and Amazon and so forth. But this microwave oven does have a problem. Looking at it from a different point of view, the problem this microwave oven has is that it has hot spots and cold spots. And so why does that happen? Well, let's start with how a microwave oven works. The original microwave oven was invented by an engineer working on radar systems, and he realized that he could use microwaves to cook food. The water molecule has natural resonant frequencies, and if the microwaves are tuned to those frequencies, the water molecules will absorb that energy and get hot. So when you're cooking something with a microwave oven, you're actually heating up the water in that food. The microwaves are produced by a device called a magnitron, which is sitting behind these electronics here. And rather than broadcasting them out into the world like a radar would do, they are confined to this little box here, and this is what we would call a microwave resonance cavity. So the microwaves enter this cavity and then they bounce around until they are absorbed by something. And that something will be food which contains water. You should really not turn on a microwave oven unless there's something in it to absorb those microwaves. Otherwise, they will reflect back into the magnetron and that can damage your magnetron. As these microwaves are bouncing off the sides, they're going to set up what's called a standing wave pattern. There'll be certain areas in space where microwaves will be in phase, in which case they add and they make the area hotter. In other places in space, the microwaves will be out of phase, in which case they will cancel each other out and you'll get a cold spot. So the microwave pattern is defined by the geometry of the box. So if you cook food just like this, some parts are going to burn and other parts are going to be uncooked. There's two solutions to the microwave oven standing wave problem. Here we have a much newer microwave oven. And we open it up and we have this rotating dish. This dish spins as the food is cooking. So the food is rotating around in a circle, going through hot and cold spots, and they average out. So the food will be heated evenly. Now inside of our microwave oven from 1981, there is no rotating dish. So how did they break up the microwave standing wave pattern in old microwave ovens? We've lowered the camera so we can look up and see the top of the microwave oven. There's this kind of loose plastic sheet up here, which is hiding something, so we will take that out. Now you can see there's some blades up here. There's some kind of a fan-like device. This device is called a stirrer. There's no motor on it. It spins freely. There's an opening here. This is where the microwaves exit into the resonance chamber. But also, there's a fan. The primary purpose of the fan is to cool the magnetron. The magnetron does develop a lot of heat. But the secondary purpose is to blow air onto this passive device here, these microwave paddles. So the air from the fan is used twice. Once to cool the magnetron, and then it is ducted up through this vent, and it spins this device, and these reflecting plates cause the microwave standing wave pattern to be moving all around. And that's how they prevented hot spots in these older microwave ovens. As long as I'm here, I thought I would just point out the simplicity of these controls. Now this upper dial here is a temperature dial. So when the food hits a certain temperature, it will shut off the microwaves. Now that device requires a temperature probe, which I do not have. So this part is completely non-functioning. Then we have 3 power settings: high, medium, and defrost. This is 625 watts. This is 450 watts. This is 250 watts. It doesn't really change the power of the magnetron. What it does is it controls what's called the duty cycle. That is how long the microwave is on and off. So when it's on high, it's on continuously. Medium, it's on about 70% of the time. Defrost, it's on about 30% of the time. And then this is a timer. That's all it is. It goes up to 25 minutes. You turn the time, you hit the start button, and that's it. It's so easy. I don't need 25 buttons to heat up coffee. All I need is a timer and a start button. So the simplicity of this thing is one of the things that I like about it. Back to the problem we're having. The cooling fan turns on after a long delay. And so for the first minute or so, you get the standing wave pattern. Food will burn on one side and be uncooked on another. It takes about a minute or so for that fan to come on. It depends on the ambient temperature. If the room is warmer, it comes on quicker. But if it's cool, it can take a really long time. And the ambient temperature in my house in the winter is probably mid to upper 60s. And it can take a really long time for this thing to start. So I either have to, let's say, put just a bowl of water in there to absorb the energy for like the first minute or so, or I will just move the food myself, like every 20 seconds, open the door and move it around a little bit. But it's a real pain, and I would really like to fix that problem. We will demonstrate. I will put a bowl of water into the microwave oven. This acts as a load or something to absorb the microwave energy, which you always want to do that. You don't want to run the microwave without something to absorb the energy. And we're going to have a stopwatch, and we'll see how long it takes for the fan to come up. Okay, we shall begin. I don't know how well the sound of the microwave is coming through to the speakers, but there's a loud buzzing from the magnetron, but the fan is not turning. Okay, the fan is starting to turn now at 50 seconds. And the fan is now blowing at full speed at 1 minute. Now this bowl of water is now quite warm. That's quite a lot of wasted time and energy. Currently the ambient temperature in this room is 78 degrees Fahrenheit. In the winter time, I will typically have temperatures in the mid to upper 60s, in which case the startup time will be twice as long. So I'm going to see if I can't find a problem with this microwave and repair it. The first thing we're going to do is we're going to remove this big metal shell from the microwave. We have got 3 screws on the left side. We'll go ahead and take those out. We've got 7 screws on the back. 1, 2, 3, 4, 5, 6, 7. We shall take those out. And we have 3 screws along the bottom. This is the left side. We will remove those 3 screws now. We should now be able to remove this can. Now with the metal cover off, we get a good look at what's going on inside. This is a remarkably well-built piece of equipment. Again, they don't build them like they used to. All of this nice thick steel everywhere. This thing was obviously designed to be serviced. Everything is accessible. Everything is held together with screws or bolts so that you can take any part of it out and replace it. This cable is carrying the 120 volts in from the wall socket. And the first thing we encounter is a fuse. Very simple to replace barrel type fuse. Then the 120 volt AC is used to charge up this step-up transformer, which steps it up to 1900 volts. That's about a 16 to 1 step up. That voltage in turn is then fed into this combination diode and capacitor. The diode acts as a rectifier to convert the AC to DC, and so we are storing 1900 volts DC on this big capacitor. And this capacitor is rated at 1900 volts and 0.97 farads. All of that voltage is used to drive the magnetron, which is this device right here. And this little device here is a temperature sensor that if the temperature gets too hot, it will shut off the current. So this is a safety switch right here. Now, as long as I have this thing open, I'm going to have a look at this capacitor here because this is a common source of trouble. Before you do anything, you probably want to check the voltage on that capacitor to make sure it hasn't retained any voltage, which I have already done. The capacitor is now sitting at 0 volts. It's been off for quite a while. 1,900 volts. I could throw you across the room, possibly even kill you. What I have here is a capacitance meter. This will tell me the capacitance of this capacitor, and it will tell me what's called ESR, equivalent series resistance. Okay, so now we're hooked up. Let's see what we get. Look at that, 0.97 microfarads and 0 ESR. This capacitor is measuring perfect. Now this device here is the fan which cools the magnetron and also drives the microwave stirrer. Now it seems to be moving pretty freely. There's a slight bit of resistance. Now the power to this fan is right here, this white and black lines. That's 120 volts again, coming right from the outside. And hooked up parallel is this line here. This goes to the light bulb, which illuminates the inside of the microwave chamber. So I know that voltage is getting to this point because this is hooked in parallel to the light bulb. The light bulb turns on immediately when you turn on the microwave. So I know that this device is getting voltage. So why is it taking so long to turn? Perhaps the bearings are getting gummed up a little bit. Perhaps we need to relubricate the bearings or something. So there's a bearing here, and then there's another bearing on the other side, and then this fan is basically dangling underneath it. What we would like to troubleshoot here is the fan. Why is this fan turning so slowly? Now, one thing we can do to make troubleshooting a little easier is to remove all of this stuff from the equation. This is an electrical schematic for reference. Now, before you do any of these things, you want to make sure that you are unplugged. We can remove all of this dangerous stuff by de-energizing it. I'm going to pull this line right here off of the input to the high voltage transformer. This way, the high voltage transformer is out. It won't be energized, which means we're not going to energize the capacitor, which means we're not going to turn on the magnetron. So we can work without any worry about microwaves. Now, here's our fan. I've connected a voltmeter to the two lines coming into the fan, the white and the black line. And that should be 120 volts AC, just to make sure the fan is getting the correct voltage. Now, the ambient room temperature right now is about 65 degrees Fahrenheit, so it's a little on the chilly side, and that's kind of what we want. The problem seems to be worse when it's cool. Okay, so I will also put our stop clock here so that we can see how long it actually takes. We will now turn on the microwave oven. And we see that we have gone immediately to 120 volts, so our voltage is okay. Our fan did start turning immediately, but it's kind of turning slowly. The fan is now picking up speed. Okay, Okay, now at 1 minute and 25 seconds we've reached full speed. Now it's blowing hard enough to turn the stirrer. So it appears the problem is not that the fan isn't turning, it's just that it's turning too slowly. We are applying a continuous voltage of 120 volts, so voltage is not the problem. The problem appears to be something mechanical going on in the fan. My guess as to what is happening is that the lubricant inside of these bearings is too thick. Perhaps over time it has dried out a bit, or it has accumulated a certain amount of dirt. So it is giving the fan too much resistance. Now, as it's spinning, it's going to heat up in these bearings. The lubricant is going to become a little more liquid, and eventually it's going to get to the point where the fan is able to turn at full speed. So that's my guess. There's something wrong with the bearings or the lubricant in the bearings. This microwave oven is 42 years old after all. It shouldn't be surprising. The question is there anything we can do about it? I think we can get this entire subassembly out. It appears to be held in by just a few screws. So if we pull these two lines here and remove these various screws, we can maybe just lift this whole thing out and get a closer look at it. Now the other thing is, now that it has been warmed up, it will spin up much quicker. Now we will start it up again, now that the fan is warmed up, and let's see how long it takes. Okay, in only 10 seconds it goes to full speed. Even in a colder room, once the fan itself warms up, and presumably the lubricant warms up, the fan will spin up to full speed immediately. But when you're coming from a cold start in the room temperature in the mid-60s, it'll take a full 1.5 minutes before the fan is spinning fast enough to turn the microwave stirrer. I will see if I can remove this fan. Disconnect the electrical connectors. Let me see if I can pull these wires through here without cutting those zip ties. And here it is. Here's our fan on the bench. Electric motor, and there's the blades. And we'll open this thing up and see what we can find out. I think we can take this shield off on the bottom. We have a number of screws that run through here. It's a Phillips head on one side, but then there's a nut on the other side. So if I hold this nut steady on this side, okay, now the nut is starting to spin. Okay, there's the nut on that side. Okay, those two came off. We don't want to lose these guys. Okay, we have it partially opened. One here left. Okay, in order to get this one out, this nut out, I'm going to have to remove the fan. It's held on with a clip. So you're always afraid it's going to fly off the room at you. Okay, we got that little clip out. Hopefully our fan will just slide off. Okay, it does. And we have got this one screw left. And those are our two bearings. Now let's see if we can figure out why they're turning so slowly. Here's our two bearings again. This is the top bearing. I'm just keeping the two screws in there just to remind me which one is top and bottom, otherwise they're indistinguishable. I'm going to lubricate the bearings with this oil. This is from the 3-in-1 company. Now this is not the normal multi-purpose 3-in-1 oil that you would find almost anywhere. That can is sort of black and white. This is the blue and white can, and so this one is designed for electric motors. You don't use the black and white type, use this type. Now where do we apply the oil? Now if we look inside of this bearing here, maybe a little bit of light. Now there's that black retaining ring, but just behind it you see that sort of gray material. It looks sort of like steel wool. It's a kind of a mesh of fibers of metal. I believe that that's sort of a wicking mechanism. I think that that's the oil reservoir in there. So that is where I'm going to apply most of the oil. I'll also apply it, between the copper sleeve and the rest of the bearing in there as well. But I think most of it needs to go in that reservoir back there. It appears to be kind of soaking it up. I mean, just a few drops should do it. Okay, I'm going to do the other bearing now, using this flashlight so I can see that mesh. One thing to be aware of is there are these little washers right on the ends of the shaft here and here. Easily lost. It's a stack of 3 of them. And I think maybe a little bit of lubrication on those is probably a good idea too. Okay, with all that lubrication in place, I think we'll reassemble our device. Okay, we will now reassemble the motor. Place the armature in first. Now the top bearing, we'll go ahead and put those spacers on it first. I have to get all that to line up. So I'm going to tilt it a little bit this way so that those spacers stay in the right place, and I will then slide this on. We then put on the lower bearing. Now the lower bearing is actually threaded, so we have to screw this in. Make it nice and snug. Now we slide on the lower plate and slip that screw in. A little bit of a balancing act here. Put in the spacer first. And we can tighten these nuts. But let's make sure we're not also twisting the screw. So I'm going to hold that screw steady, and I'm going to tighten the nut. Okay, these 2 nuts are now tightened. And now we have this one last nut to go up here. With everything nice and tightened up, we now put on the fan, and make sure to put it on the right way, because you could put it on accidentally upside down. Okay, this is the way it goes. And now we put our little clip on, and this is the part I always worry about, having the thing like fly off on me. Fan is on. Now we just need to put on our shroud. It's pretty easy to see which way it goes on. There's really kind of only one way. Okay. Okay, now we put our screws back in here, here, and here, but not here. Okay, our fan is completely reassembled and ready to put back in. We'll now place the reassembled fan and motor back into the microwave oven. Best to start sideways like this. And we reconnect the 120 volt lines. Now the microwave oven has been plugged in again, and I'm going to go ahead and test the fan. It goes to full speed immediately. In fact, it has never blown that fast. It appears the problem was lubrication. Our fan is now operating properly. And that means that the microwave stirrer should start turning immediately as well, and that should fix the problem of uneven heating with hot spots and cold spots. Okay, it looks like our fan is running good, and so now it's time to reassemble. Remember, unplug the plug for sure. And now we will reconnect our high voltage transformer and magnetron. Now, as far as getting the cover on, you've got to line up all of these little tabs with corresponding slots in the cover. And the slots are these little guys like here, 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 here. But that you have to mate those up, okay? And then you can slide the cover on. I've put a tiny bit of lubricating oil on all of these little tabs here. Hopefully that'll help this thing slide in a little more easily. Back screws are going to go on first. Screws on the right side. Left side screws. And now our fan is spinning up normally, and therefore the microwave stirrer is also spinning up normally. Hopefully this will put an end to the hot and cold spot problem. Thanks for watching.